Okay, now let's go through a whole example of doing a whole hypothesis test. So we've got some sample data here. This is a simple random sample of front seat occupants involved in car crashes. So the car either had an airbag available or didn't. And we have here in the table, we have the number of occupant fatalities out of the total number of occupants. So out of the 11,541 crashes where an airbag was available, there were 41 fatalities, and out of the 9,853 where no airbag was available, there were 52 occupant fatalities. So we're going to use the sample data and a 0.05 significance level to test the claim that the fatality rate of occupants is lower for those in cars equipped with airbags. Now this is one where if you saw this problem, you might have to think a little bit to realize that this was dealing with a proportion. When we're talking about the fatality rate, we're talking about the proportion of occupants out of the total that died. So we have our proportion of occupant fatalities is the same as our fatality rate. And if we want to compare the proportion of fatalities for those with airbags and for those with no airbag, we would look at this as two different populations. So our population 1 is those with an airbag available. Again, this was the first column in our table, and it was also the first one that was mentioned in our claim. And our population 2 is going to be those with no airbag available. So step 1 of our hypothesis test is to write our claim. So the fatality rate, and again we can make this specific so we remember it's a proportion. This is the same as the proportion of occupant fatalities is lower for those in cars equipped with airbags. Our parameter is the difference of the two population proportions, so it's P1 minus P2. And what inequality should we use? The claim says that P1 is lower than P2. So this translates to a less than. So we would first write our alternative hypothesis as P1 is less than P2, and then rewrite it as P1 minus P2 is less than 0. So there's our alternative hypothesis, and there's our null hypothesis with an equal in place of the less than. Now for step 2, in this case we were given the alpha, but we still want to think about what a type 1 error would be. This would be supporting the claim that the fatality rate is lower for those in cars with airbags when this is not actually true, meaning that the fatality rates are the same whether they're airbags or not. Now this error could lead to extra expense and extra regulations involving installing airbags in cars when it really doesn't save any lives. Now again, we were already given the significance level to use. This would be alpha equals 0.05. Anytime you're getting into two samples, the calculations get more and more intense, so it's a good idea to use some kind of software to help you. So to use StatCrunch, since we started out with summary data here, we would want to use the procedure that does a two-sample proportion with summary. So in here we need to put in the number of successes and the number of observations, which is our sample size, for each of our two populations. So we have 41 and 11,541, and for sample 2 we had 52 successes out of our sample size of 9,853. And notice here that when we rewrote our alternative hypothesis and our null hypothesis, we had a 0 on the right side, so we just use a 0 here. Our inequality was a less than. And here's the result we would get. And notice this gives us a whole bunch of different pieces that actually are part of our formula in our test statistic. So we've got our number of successes and our sample size for each of the two samples. The sample difference, if we look at our formula, the sample difference would be this part on the top. The first sample proportion minus the second sample proportion. So there's our sample difference. Our standard error is the part of this formula that's on the bottom. It's actually our standard deviation. So this whole thing, the square root on the bottom of this formula, would be our standard error. And then z-stat is telling us our test statistic. So that was negative 1.91. And this also calculates the p-value, which we found was 0.028. Be careful with this because there is a difference between hypothesis tests and confidence intervals. Confidence intervals, for one thing, are always two-tailed, while hypothesis tests can be one-tailed, just as in the last hypothesis we just did. So they are not always the same. If you want to test a claim about two population proportions, you should use a hypothesis test. If you want to estimate the difference between two population proportions, in that case you should use a confidence interval.